Hi. I'm just waiting for a few more people to join, then I'll get going. I'm going to start at about 10 past 10 just to allow any further stragglers to join in. Okay, I'm gonna get going. Hi, welcome. In today's Python workshop, we're basically gonna take all we've done so far to this point. That we started with a basic workshop that just produced Python. Then we went on to a workshop that covered the basics of what classes and modules are and how the object-oriented side of Python works. Then we continued into an introduction of NumPy. After NumPy, we did some pandas and how that correlates to NumPy. And what we're doing today is I'm just going to talk a bit about Matplotlib. And Matplotlib is basically a very nice library for drawing graphs and representing data in all kinds of intricate ways. It's got a lot of correlation and connection to MATLAB, and it's got a whole subsection of it called PyPlot, which is inspired by MATLAB and designed to be a million easy to use for MATLAB users. So what we're going to be doing with all of this is today I'm finally going to give you guys your first, I'm calling it a post-workshop submission, but it's basically just a personal project that you take all that you've learned to this point and you use that knowledge to build a project, and then you basically submit that project for review. And that's a very scary sounding turn of phrase, but what it basically means is that you get to go and say, okay, as I understand everything, I put together this thing, and then someone else looks at it. In this case, it will probably be me. It will definitely be me. Looks at it and then goes, okay, I see you understand this concept based on how you used it here. I see you misunderstood this concept, how you used it here. Basically, just based on how you go about writing something, help guide you to improve your own skill in coding. So, commonly in the workplace, there's something called peer review, where if you work for someone or with someone, then someone else looks at the code you wrote and then gives you feedback on that. It just to helps you develop as a coder yourself, as well as sometimes it's good to just hear if what you're doing is right or wrong. Code review is one of my favorite parts of working with people. I love getting my code reviewed. Yeah, so I'm putting this post workshop submission up to allow you guys to firstly experience Git a bit, which I'll run through the explanation of what that is and how you'll be using it, which is one of the industry standard source control platforms. And what source control is it's basically a way to uh, be able to say, okay, the code changed here by this, and keep track of that and saying this person did this person did that, this is what was added, and it allows you to incrementally update your things. So I won't, in this workshop, be doing a in-depth Git guide, as it's not quite necessary to understand the software in such depth to be able to simply use it. So all you guys will need to do for this workshop is you'll need to create your own account on, we're going to be using GitHub. I like using GitHub, but it's recently made itself free for everyone, a lot freer than it was with its previous licensing restrictions. So I'm going to say create an account on GitHub and then use GitHub desktop to sync your code. And I'll guide you guys through that process. We'll basically just guide you guys through that process. For creating the GitHub account, you can do that yourself. It's creating a normal account. But for how GitHub desktop works, that I'll just show you guys roughly and just create a small repo for this workshop as well. Okay, so I'm going to start there. So what I'm going to do is, after you've created your GitHub account, you are in GitHub, and it will look something like this. You just click at the top right, you create a new repository, you give it a name, Cool. In this case, I'm just going to call it this. You can call yours anything that makes meaningful sense to you. And then you said whether it's public or private. Public just means that it's out on the internet and anyone can see it. Private means that you can whitelist users or get a shareable link or something like that. For this use case, I'm just going to mark mine as private. And then the get ignore and the licensing part of it, there are very good reasons and use cases for that, but for our use case, they are not as important. If you're interested in how to use them and do that, there are very excellent guides on GitHub itself, or you could ask me on the contact details I provided at the bottom, and I'll give you an in-depth explanation. I just don't want to purposely re-explain things everyone's aware of if there are. If not, please do let me know and I can go into depth about that. Okay. Then you just create your repository. There you go. You've now got a repository on github.com. Fantastic. So the easiest way to then interact with this repository, which is then basically a thing where you will put your code to and it will keep it on a cloud for you safe and you can update it incrementally. The easiest way to do that is using GitHub Desktop. So there's a link for GitHub Desktop also in my notes that you can get there. But then once you've installed GitHub Desktop, it will ask you to sign in, and it will sign you in with github.com, and then you are signed in. Cool. So now to actually interact with this repository that we've now created, this project. A repository is sort of your folder that it tracks where your project is inside of for changes. So the specific folder of what we want to use this repository. So we're going to just copy this line here, or because we are using GitHub, there's a special feature from them where we can clone a repository. Because we are signed into GitHub with them, I can simply filter my repositories for GirlCode Workshop 5. Then I select where I want it to go. I'm just going to put it on my E drive, and there we go. So what cloning means is it's basically downloading the repository that exists on the cloud to my local computer. And because there's currently nothing inside of this repository, it's going to just make us a new folder with the repository name, and there we go. So now, because we're using Visual Studio Code, there's some very nice integration with GitHub Desktop and GitHub and all of that, all nicely together for us. So what we can do is we can just say, open a Visual Studio Code, and it will open a new instance of Studio Code for us. In here, it's empty because we don't have anything yet. So we're just going to create our folder for today, file for today, and then I'm going to give my file. I'm going to just create a file for today, and then my file is going to be workshop 5.py as usual, but it doesn't matter. This is just an example of how you would then interact with it. Cool. So then how GitHub works, and Git specifically, GitHub is an online hosting platform that uses the software Git as its main component. GitHub is just an online cloud-based storage solution for your Git projects now. So your repositories and all those things. So how it works is it's based on incrementally sensing changes and saving those for you. So let's say I were to go and say, hello new repo. Because this is a new repository, I'm just going to do the equivalent of hello world. So if I save this file now, and then I go back to my GitHub desktop, then here we can see it says workshop5.py, the file that we've created, and there we see the text. So then here at the bottom left, there's an option to say commit to master. And what commit to master is it's basically within GitHub, you can track your changes, but then you can also branch off and basically do a side project or develop features separately. You can separate out the different bits of development that you are doing and then combine them back into your main avenue of development or your main branch of development, which is called master. It's your master branch. So you always start from master branch and then you can add multiple separate ones on the side. If I say commit, then it's going to just process that commit. And then if I go here to history, we'll see there's one with the default text that it gave me, which was create workshop 5.py. And we can see here that it says I added the line. So now, very importantly, I now have a commit and it knows what my changes are and all of that, but that's all still very much locally. So it's still all on my computer. I go back to my webpage here where my repo is open in GitHub.com and I refresh the page. It's still not going to be online. It's still very much locally. The way you make it online is there is this publish branch button. And later when you make other commits, it will not necessarily be publish, it will be push commit, which just means upload to my remote, which in this case, remote refers to the online storage where my stuff is stored, which is GitHub. So if I say publish, because it's the first ever anything I do, it just creates the thing on GitHub for me. So there it goes. That's all it's processing and done. Now I have my first change. And if I go here to Chrome, if I go here to Chrome and I refresh, you can see here is my file and the text inside of it is the same. So then if I now change it, if you are familiar with command line prompts and you know Git and GitHub, you are more than welcome to follow that avenue. I'm simply showing it this way for people who have never used Git, and the command line might be slightly daunting in that aspect. But yes, you're more than welcome to. Personally, I also prefer the command line because there's a lot more command controls and you can do different things specifically. But that might be daunting to someone new to the technology. Cool. So now I've got my hello new repo, and then if I then add a second line, which is this is my second line. I go to GitHub, you can see that it then has, it says there are changes to my file. It has a default name for this commit, which is update, and then I can provide an optional description as well. And all of that will then reflect back on GitHub for you. So if I commit this, so mark this place that I'm at with my code at the moment as a specific place in time, and I push it. And then I go back to my browser. We'll see that my file is now updated, as well as now this says I have 2 commits, which is then my 2 different ones. So that's just simply a basic introduction to what Git and GitHub is, and how commits work, and how you can then incrementally make changes. So if you then change a specific element in the line, it will then just send those changes along, not the whole file from scratch again. So it's just a simple, nice way to manage changes to your code, to control what happens to your source code, so source control. Yeah, so that's just an introduction to what Git is and how that works and how you can then upload and submit your own personal project. Cool. So I'm not gonna use this repo I just created for that, because I've already got the repo up and running for my workshops. But you can put all your code in there, and your project you can put in there and all that. Cool. So then I'm going to jump into what we're actually doing today. What we're doing today is we are just doing a basic introduction to Matplotlib. Sorry, I've now lost this chat. Cool. We're going to just do an introduction to Matplotlib and run through the different terminologies and what I do. I am using, as I linked there in my notes as well, very well noted and laid out tutorial from Matplotlib themselves to just have content to do base what I'm saying on, as well as then have it different somewhere else. So I'm not just saying things the way I believe it, but it is actually by the people themselves. So that is fairly nice. Cool. So so far we've used NumPy repeatedly. Okay, so we've got NumPy that we've used repeatedly, and then for some of the examples that I've used before, I've already had you guys install Matplotlib. So if you missed that part of any one of the previous workshops, or you don't know how to do it, or something goes wrong, then simply let me know, and I'll assist with that. But basically, we're just going to be importing Matplotlib again. And then we're going to use the pyplot subsection of that. And it also has a somewhat standardized import fashion that you import it as, which is this. Cool. And then there we go. We've now imported Matplotlib's pyplot. So there are several parts that make up each one of your graphs that we're going to be drawing. And those graphs can be explained as a few simple basic parts. And I'll explain what those parts are. So we're just going to be using pyplot. And then to just have a quick example, I'm just going to put some things down to base what I'm saying on. So what this does is it just uses pyplot and it plots some values down. And then I'm going to want to manually define a label on the y-axis in this case, which I'll explain now when the visuals come up. And then the important one in this case is the show command, which is just a function call to pyplot and Matplotlib itself, and that just makes it actually show the graph. Then if I run this code, what ends up happening is we get this little graph. And as you can see, it has values on the y-axis, and it has a x-axis with the values that we've defined here. So basically, the few different parts that make up each one of these plots, you can only really see them if you use them the other way to use pyplot. And I will show that to you shortly. I'm just showing this one first. This is that pyplot that is similar to MATLAB that I explained earlier. And the reason for that is you can simply just say, plot me some values, and you put any list in there, be it a NumPy list, be it a standard Python list as this one is. It's just you can put any values in, you can put some labels on there, and you hit go, and there you go, you've got a graph. But now say I wanted to later in my code, if the user does something, change this 3 to a 4. I wouldn't be able to do it because I just simply threw the values at it and made it do its thing. So now comes the other part of Pyplot, which is you can use Pyplot in an object-oriented way. And the way you go about that is you create some variables and then you assign some function calls to those variables. So how you do that is you go, and let's create a variable. We're going to call the first variable fig, and there we go. And then I'm going to put a comma, and I'm going to put x, and then I'm going to just put it equal to plt dot subplot. There we go. Sorry, subplots. So what this does is it creates firstly a variable that contains the figure. And then secondly, it creates an axis. And what an axis is similar to that graph that we just had. An axis is basically a single graph. So what we're doing is we're creating a single graph and we're setting the single graph equal to a value. So now if I run this, it's going to do absolutely nothing. And the reason it's going to do absolutely nothing is because we haven't actually really told it to do anything. So previously we went plt dot show, and that showed us our graph. But in this case, if we call plt dot show, it's not referring to the specific object we've created now. It's referring to if you were to go and say plt dot plot and then put stuff in, or use any of the other graphing functions that I haven't yet shown you guys. So you can't then just plot the specific, the generic, all of pyplot, anything I have to find a new plot that you can't do that anymore because we don't have a showing, it doesn't know what to show because it's all saved into a specific object when we created our object. So what you then do is you can then take your specific figure and show that. Let's just make that line. And then there's currently nothing in it, so it's not going to show us anything. Of course. Actually, I believe we're using Python 3, so you should be able to. Yeah. So we're using Python 3, which uses the updated version of Pyplot. So I actually stand corrected. That's actually really cool. So with the new version of Pyplot, you can show your graph with the PLT still, which is really cool. So basically, we've now defined a figure, axis, and we set the subplots. But we never plotted any values into our subplots. So it's simply giving us the most bare basic of figures, which contains one subplot. So that's really cool. Actually, learning a lot with you guys, doing my workshops. It's cool. Okay. So now we've got a figure and an axis, and I defined what an axis is. And there's just one distinction I should point out. The x and the y axis is still an axis, and those are your axes. But Matplotlib has a thing called axes, your axes. It's spelled with an E, and that just refers to that, what I defined as the separate little graphs inside of your different things. Cool. So now we've got an empty one of those. We probably want to put some data inside of it. So what I'm going to do is I'm going to use the data provided for us in that guide I spoke of earlier. And what that is it's simply a dictionary that contains some data. So it's basically just a dictionary It contains a bunch of company names and a bunch of values attached to those company names. And that's that. So because it's a dictionary, and we've used dictionaries before, we know we can access the values, that would be the second part of it, and the keys separately from each other. So we're just going to extract those data, and then we're just going to plot this data as relevant to these names. And then instead of just plotting them into a graph, we're actually going to use a specific graph. And the graph that we're going to be using is we're going to be using the BARH, which is basically just your normal bar chart. So it's a horizontal bar chart. So it's a bar H. Cool. So to extract the keys and the values from our dictionary, all you do is, I'm just gonna get a variable called keys. I'm gonna put it equal to a new list. And what I want this list to be is simply our data values data keys. Cool. And then we want the same thing for the values. Cool. So you're basically just wrapping the keys object inside of your dictionary into a new list, putting it in a variable, and doing the same thing for the values. Cool. So now we have our keys and our values. We want to put them on our different axes. So your keys or your names of your things. So you want them to be on your y-axis, and then your values you want to plot on your x-axis. So then if we take our axis, which is this guy, do a bar horizontal, then you first put your y-axis and then your x-axis. So in our case, we want our keys, and then we want our values. Cool. And then we want to have it drawn for us. Let's see what this looks like. Cool. There we go. We've got our y-axis with all our keys. We got our x-axis with all the values. So now Matplotlib and Matplotlib provides us with a variety of styles, and all of those are nicely documented in the documentation. So you can go look up a style we like and all that. But in this specific use case, we don't have to necessarily go look up a style. Actually, there's a cool other thing we can do. We can go print, and then we can go, what is it? Actually, one of it's in this guide, it is, yes, awesome. Basically what that did is there's a variable inside of Pyplot called style, and that class basically has all the available styles that you have currently loaded, that you can install more modules that contains more styles. Can I paste the dictionary for you? Yeah, no problem at all. Let me paste you the dictionary. Cool. Sorry if I missed something in the chat. It is not on purpose. It is off to a side screen. Cool. So there's the dictionary. Okay, so basically this class style has a list of all the available styles for you, and you can install more modules that contains all kinds of different styles, and then you can read their documentation to see how their styles look, and there's also nice examples of how they look. But there is a nice one that works nicely for this bar chart. So I'm just going to tell you what that one is. And in this case, we want to be using a style. And how you use a style is you actually just go PLT, which is your pipeline of style. And then instead of using that available that we were using just now to see all the available ones, you just specify use, which is a function. And then you just say the one you want. In our case, it's 5, 30, if I can spell. Yeah, 30, and then 8. And what that does is if we run out a little bit of code, and it's not already on it. We run out a little bit of code. Come on, come on. Copy that. This. Okay, mine is not playing along with me. The reason for that is yes. So the reason for that is these function calls allow you to define the style after each graph that you've drawn, basically. So you can use one style for the one graph, a different style for the other graph, and then you can have all kinds of different graphs on the same figure. And the figure is basically this window that we've got. This is figure 1. So this is your nice window. So basically, the reason I had a problem there is I defined my style after I had drawn my graph. So it didn't use the right style because the style wasn't defined yet at that point. So what the 538 one does is, if you look here, you see there's some nice lines now. And it just makes the graph make more sense. Cool. There we've now got our graph. But now your graph is just values without any meaning really attached to it. So earlier when I used just the PLT instead of referring to a specific access, so instead of storing an access to a specific variable and then keep modifying that variable, and I was just defining my different plots and my different axes, I was able to just go Y label and I would put a Y label there. And that isn't quite what we want. That wouldn't quite be applicable here because we're no longer using the Matlab style of going to things. We're using the object-oriented style, and we're actually saving it into a specific axis. So now you have to set the label different. And the way you go about that is here, after we've drawn our graph, we go AX referring to our axis again. And then, oh no, autocomplete is gone. I think I'll work on autocomplete. It's quite possible. So I'm just looking on my second screen, seeing if I can adjust my. I cannot. Okay, I won't be able to fix my autocomplete now, but that's fine. So basically, instead of now just saying the Y label in general, or the X label in general, we now have to refer to specific axes. And now that is a variable inside of this axis. So the way that you access that is you use set, which is a function. And then what this function takes in is it takes in different name parameters. So in our case, the name parameter that we're after is our Y label. So we say Y label. And if your autocorrect is working, it will list you the different ones. In my case, I broke mine. So mine won't do it, but yours should. If yours doesn't, please let me know and I'll advise you how to fix it. It just requires a restart of your editor, which will make a project of quicker and then the back. So I'm not gonna do that right now. Yeah. So you say Y label, and then you define what your Y label is. In our case, I'm going to say it's companies. So now we refer to our specific axis, which in this case is our specific bar chart. And it's Y label and companies. Spell. See if I can spell. I cannot. Cool. Companies. So now if we run it, we'll have a Y label. Later on in this workshop, I'll show you how to just make things fit in a bit better. And then you'll see my Y label. So for the example sake, I'm just going to also provide an X label so you can actually see in action what I'm referring to. And in this case, it is annual revenue, because I've decided that these numbers represent the annual revenue of the company. So I run this. You'll see at the bottom, you can see annual revenue. So to the left, it will then say companies. Cool. So now we've got our X and our Y label. Another one of the things that you can define for an axis is you can define it a title. So title is also just a named parameter for this function. So you just put down title and set will pick it up and apply. And then our title is companies and companies we revenue. Actually, we call it companies annual revenue. Cool. We've got a title, we've got our X and our Y. Now everything is still very stretched. So now there are multiple ways that you can go about making your data fit into a specific value. And the way you go about that is you set your limits. So in our case, ours is way too stretched on the x-axis. So now, if you want to limit it to the x-axis, the maximum space it takes, it's x lim, and you set that equal to a range between min and max. So in our case, let's say, what do we want that value to be? Something like 3, 4. Let's try that. And then our maximum is 1, 4, 1, 2, 3, 4. So now you can see what we're basically affecting here is we're affecting the limits of our values here. That isn't affecting the actual size of it, but we're affecting how the value is represented in scale. So if your showing too many values on your x-axis, it's gonna completely warp your graph out of scale. You don't necessarily want to squish your graph just on the pixel scale. You want to actually put it inside a meaningful data grouping. Okay. Sorry, I've now lost my place in my notes. Let's go too far. Go. I have found my place. Okay. Now we basically have a graph, and we're drawing values inside of our graph, and we're using Matplotlib as a variable, and we're saving out instances of this graph that we're using so we can modify the values on it. What this allows us to do is we can then also now draw secondary graphs and tertiary graphs and all those kind of things if we have multiple values that we want to draw. So for this example, I'm going to say we don't necessarily want to. I also see that our x limit of -1000 push the extra space here, which we don't need. So we set that to 0. Run this and go again. Now that extra space there no longer exists. Simple as that. So where is the thing that allows us to edit things? Ah, I found it. Okay. So we still now have our scaling problem, even though we have our cool labels and things, and we can't necessarily see them. And one of the main reasons that we can't really see what we're doing is that all our values are displayed next to each other flat. So another cool thing that we can do is that we can get the labels back from a specific graph, because we've now got it saved as an instance. So if we want to get all the values along the y-axis or the x-axis and then perform actions on them specifically, we now can. So let's say we want to get all the values along the x-axis and just rearrange them a bit to give us a bit more reasonable space to work with. So as an example of how you would go about doing that, let's just create a new variable. We set this variable equal to our specific axis that we're referring to. And then we want to get, because we're getting a collection of things, in this case what we want to get is we want to get our each one of these, oops, of course it's going to fail. Each one of these points on our x-axis we want to get is referred to as the tick point, because it ticks along the values. So it can be a step or whatever, but the representation that is used in Matplotlib is a tick. So if we want to get each one of these ticks as labels, we would go and we would say get x, and then it's a tick label. We want to get all of them. There we go. So now we've got all our labels on the x-axis stored into a variable. And now we can just modify these values. So to modify these values, you can't just perform operations straight on the the labels, because it's now a list of values, and each one of those values represent a data object that is one of these tick labels, right? So technically you can loop through them and set each one of their values to be a specific thing that you want it to be. There's nothing stopping you from doing that, but Matplotlib provides a function that you can, similar to how we in Axis with set, we set the Y labels, the X labels, the title, and all those kind of things. You can set specific values for all of those using a function. And that is, we use our piplot from Matplotlib, and then we want to set p, so set parameter, and then the parameters we want to set all live inside of our labels. Oops, our labels. And then what we actually want to set is we want to horizontally align them. So horizontal alignment, and then so that right aligns all your values. So that just means that they are shifted to the right in the alignment. I'm not sure if you guys are familiar with how alignment works in HTML and those kind of things, and how that like alignment groups in a graph scene mode UI format. That is a terrible sentence. Sorry. So there's a way that you do UI that is called graph scene layout. A terrible technical term that basically just means you predefine all the values, and then how they are aligned and all that has specific behavior set. And one of those ways that you can align things is you can then say your horizontal alignment, you want to align right or you want to align it left. That moves your values to the right or to the left, dependent on the horizontal axis. But then you can also say align something to the top left corner, and then we'll just align it to the top left corner of a specific containment shape. So in our case, each one of those tick labels has its own little box that it lives in. And we're just saying in the horizontal axis of that, please just move it to the right of the predefined box that this label exists in. So then the other thing we want to do is we want to rotate these. And we're just going to rotate them by 45 degrees. So what that then does is we basically get all the labels that exists in our axis, which is then in our case going to be our x values, which is an integer number of some kind in that range that is limited between 0 and 140,000. And it's going to take all of those labels at the bottom for each tick in the x-axis, and it's going to shift them to the right in the alignment box. And then it's also going to rotate them 45 degrees. And that's all we have to do to affect all those labels. So let's have a look. Unless I spelled horizontal alignment incorrectly, which is fairly likely. I did. There we go. So now all our values are nicely rotated and shifted to the right. So if you look here in the nice cutoff values, they've all moved to the right a little bit. And yeah. So now, oh, I was looking for a way to insert this without making it wildly weird. I'm gonna unfortunately leave you guys with this being wildly weird. basically, all our cutoff things that we have is cut off because the figure that we have and the axis that we're drawing inside of the figure is similar to how we're right aligning our things. The alignment is off with our figure. So we want to basically just scale everything to nicely fit inside of our actual window. So the way we do that is we go and we say pipeline, and there's a thing called RC params. There we go. And the RC params is to do with the rendering, and you can set the style sheet, and similar to the styles we have, you can define your own and all those kind of more intense functionality. But basically, we want to just update that. And what we're going to be updating it with is an object that contains basically a dictionary. So we want our figure, auto layout. And we're setting our value to draw. After our code, everything nicely fits in. So similar to how with these, how they are now right aligned, the figure itself also fits inside of a block. And what we just did is we said, just please automatically scale it for me. Basically. Yeah. Sorry, it's not a simpler way to guide you to that process. So I'm gonna leave that one as vague but a line that is important to make it work, which I dislike doing, but I hope that makes sense. Okay, so now we've got our graph, and we did some layout things, we got some of these. So now when you get some of these values, you can do specific things with them. So because you can get all their labels, and if you get the label and you get the text in the label, you can get back to your data and you can get a specific one. And then based on that specific one, do specific things with it. So for example, I can go and I can say, if I add if I have a thing where I want to go, this company earned less than the average 10% of them, which I can calculate using the techniques we discussed in our previous workshops. I want to do this and this to this specific label. So if Barton LLC that worse than 50% of them color the label red, then you can do it simply through the same process where you just set that specific one to then be red instead of sorry, you can set it to be red instead of the standard black. And that's a thing that's simple enough to do as an example. Cool. Cool. So now we've got our specific axis, and now we can do things with it like I just described, with setting specific things in it. But because we've got our data, we can also do more generic things. Like the first statistical thing that we actually did is we calculated means. So let's do the same thing, where we calculate the mean. So if we go and we say the company's underscore mean value, so that's your mean annual revenue in our case, because that's what we've decided the value represents. So then we can do numpy dot mean, which you guys know, and then we can go and we want to just calculate the mean of all those values, which we already then have in a variable called values. There we go. So now we've got our company's mean annual revenue. So if we actually want to represent this mean annual revenue on our graph that we've got, the way we go about defining that is because we've got our axis, so we've got that's where we draw it, some styling for our graph itself. This is labels, that's all labels. Cool. So now, after we've set all our labels, before we draw it, we want to just represent this mean value in some way on this same graph. And the way you go about that is we refer to the axis, which is our specific graph, which is our bar chart. And then what we want to represent is we want to represent the mean, and we want to represent it as a line on our graph. So we go AX, which is just the API start for axis. V, and that V represents vertical line. So AX V line, or axis vertical line, is a function that exists inside of axis that takes in a value. In our case, we've got a value of company's mean. I'm just gonna rename to none of the cap. Manually rename out of that. Cool. So now we're going to draw a vertical line on the mean axis. And then your line, you can also define parameters to. And your parameters are stuff like your color of your line, your line style, all those kind of things. But let's look what we've got at the moment. Let's close this guy, run our new code, and there we go. We've got a line on our graph now, and our line represents our mean. Cool. Cool, we've got a line now on our graph. So now that styling I was talking about that we can apply, let's do some of that. So if we want to apply styling to our line, it works similar to when you set the values, except because we already know what we want this line to look like, and we know what things we're going to set up for our line, we can already define them at the line creation time. So one of the ones that I mentioned that we can define is our line style. So let's say we want our line to be a dashed line or a dotted line. All you do is you say ls for line style, and you set that equal to a value. So you can do dashes, underlines, dashes or spaces in them. So we're going to use dashes. And then some of the other parameters you can define for your line is color. And we can just set that to red. Run it. We get a line that is red with dashes in it that represents the mean. Cool. There we are. We've got a few additions to our thing now. So now it can get interesting. What we can do is we can define basically same thing as this full processor for we want to set the parameters of each one of our labels. We can also go and we can define a specific function that does this for our different labels individually and perform some logic on those functions. So that's like where I said if a company earned less than a specific amount, we want to turn it red, for example, and those kind of things. So how you would go about that is you would then define a function as you would normally define a function. So I'm just going to define it at the bottom. You can define it at the start too. Actually, I might define it with our data processing while we're data processing is defining tag. So you do your define. And in our case, we know each one of these values is a currency value. So we're going to do a currency formatter. So what these actually what I want to do is here we get our labels. We say percent. We do that. We run it. Of course. We run it. Here we see its major tick label objects. Right? So if we get the first one, we want to see what that looks like. We can see that it defines text 0, 0, and then a value. In our case, you can see it's 0 over the 2 axes, and then its text is 0. Cool. So with that, that's just to illustrate what this object looks like, so that the function definition makes a bit more sense. So then when we do our currency formatter, what we do is we take in 2 parameters. And what those 2 parameters are is it takes in the x value and the position. So what we only really want to do is we want this formatter to change the x value, which is the tick value, the actual currency amount. So if we define our function, and then we say if our x value is greater than 1 E6. And the reason I'm using 1 E6 is simply because I lose track of zeros. So E6 just refers to your amount of zeros for you. Then we're going to have a new variable, and this variable is the variable that's going to be returned by our function, because our currency formatter takes in the values and then converts them to a currency value for us. So if our x value is greater than 1 million, we simply want to add an m at the back. So what that would look like is we go f, this is our return variable, and s is equal to then it's a R. And then I'm going to use a new command, function I haven't used before, which is the format function, which is just the function that you can use on the strings that allow you to use the notation of circular curly brackets inside of your string, and then at the end when you go dot format, it replaces out the values for you. So basically, what we want to do is we want to say 1.1f, and then at the end we put a m. So basically, it's gonna be replacing this bit in here for us. So it's going to say R, the value M. If it's more than 1 million, it's just going to make a shorthand notation for million. So dot format is the function, and then our value is x. So we go x times by 1e minus 6. So basically what it does is, if it is more than or equal to 1 million, it will take whatever our x is and replace this with our x minus divided by 1 million, basically. That's what that string operation there does. And then the other one, s is equal to, and then so if it's not in the millions, it's going to be in the thousands. So we're going to use that same code we just wrote, except now that becomes thousands. And then instead of removing 6 zeros, we're going to remove 3 zeros because the k represents times 1,000. So if it's 100k, it's 100,000. If it's 10k, it's 10,000. The k just becomes shorthand. Cool. So now we've got our function that we want to use. So to make that function work with Matplotlib, the way you go about that is you have to actually wrap it inside of some of their logic called the function formatter. So you just define your function as a function formatter. So we create a new variable, and we're just going to call it formatter. We're going to set that equal to func formatter, which is currency formatter. So now our function is now this new object called formatter. It's just wrapped nicely to be used by Matplotlib. Cool. So the way we go about actually making this formatter now do something for us there's one thing I left out that is slightly important. This func formatter isn't just a thing that exists. It's actually imported from Matplotlib. So at the top, you just want to import the ticker. So when we got the tick labels, and then we use the set b and then the find labels. What this Matplotlib.ticker does is it just does it for each one of them. So it wraps our function nicely in a thing that is used by Matplotlib on each one of our labels then, right? Cool. Sorry, that is slightly important. Cool. Now we've got our formatter, but it's still not being used. It's just nicely wrapped into this formatter object for us. So then to actually go about using this formatter, and we want to use it on this axis, on the x-axis. So after we did all our changes to all our different things, and we drew our line and all of that, we can now go refer to that axis and then say that the x-axis of it, because we want to be changing the x-axis, we're going to be setting a measure formatter, and then you just feed it in your formatter object. So basically, our function is wrapped into a class that makes it perform that action for each one of our labels, and then that class is just fed into the specific axes, the specific axes as a thing that does something. So now when we run it, I didn't leave out a colon. I made a mistake somewhere. That's all our values. Oh. Ah. Got my font formatter, got my currency, yes. Create a new formatter, and define. Got a warning that says deprecation warning, the format module is deprecated as well. Okay, that is interesting. Here at the top, where you import it as func formatter, are you importing it as func formatter, FUNC formatter, or are you importing formatter? Because it might be confusing it with a built-in module that you have.
So I import func formatter, but it says import formatter.
So basically, that's what you should be importing. The from matplotlib.ticker is an important.
Yeah, okay, thank you.
Oh, no problem. I have had a similar confusion. Cool, is that making more sense and functional now? As your deprecation warning gone away and now runs.
All good. Yeah, it was my my mistake.
Oh, no,
One
no problem
line.
at all.
Yeah.
No
Yeah.
problem.
Now all is good for me.
Awesome. Okay. So then that is how you define a formatter that then runs on each one of your separate things. So then one of the things that you can do is you can then, these text that we've been using and how they function, we've been using the auto-generated ones that it decided makes most sense for our specific thing. So we don't necessarily want to use the text that they defined for us. We might want to set our own. So you can do that. And the way you go about that is you say AX, which refers to your axis, which is your specific graph, then set, and then X, X. Cool. So then basically you can then in here put in a list that defines the range that it's going between. So for our use case, we want it to be 0, 25,000, then 50,000, then 75,000, then 100,000, and then 125,000. Then you can, now if you run it, you will see that your ticks are 25, 25, 50, 25, 100, 125,000. Cool. So you can define your own ticks. And that's fairly useful if you have your own data that you want to represent in specific ranges. Or we often see graphs in a newspaper have some really weird stepping in their graphs. And the reason for that is because depending on how you change your stepping means that you can make data be represented in a specific way. So you can skew the view of data in a specific way, which can be useful or can be malicious, but that's relevant. You can do it, which is the point. I think I've misused my format here. So my currency formatter was not functioning nicely. And it took me a minute to just process why this was happening. And the reason this is happening is because we are setting this variable x, and that's it. What this function wants is it wants us to return the value that it should display in this x. The way you do that is just a normal return, and then you say your value. So now if I run it, then you will see our value is here, 0, 25k, 50k, 75k, 100k, 125k. And that is the expected behavior. It just took me a minute to figure out that I did not actually ever return the value, which is fairly important. Cool. So that is how you can use those formatters, and then you can do them on specific of those values, do specific things like make one red, for example, as I mentioned. You can do those kind of things. Cool. So now we've drawn lines, we've put values in a table, we have used the median of those values to put more data in a table, and you can do all kinds of things like that. You can also specifically for specific values in your data do specific things, or insert extra values or data for those specific elements in your data as well. So the way you can do that is you can then annotate specific stuff to specific you can annotate specific information for specific values in your data. So basically what you can do is you can, let's do an example. So what I'm going to do is I'm going to say, okay, I want to annotate some more data in there. And the way I want to do it is I want to go and say for value 3, 5, and 8. I want to create a new entry, basically, a new annotation that I want to add into my my graph, right? So the way you go about that is I'm just going to loop through my list, which is element 3, 5, and 8. And then for element 3, 5, and 8, I want to add an annotation, something specific. So because I've got reference to my axis, which is the graph, I can go and say this axis, I'm going to do a bit of text, and then this text, I'm going to put way past all my data. So this is just where in your, yeah, I'm just going to put it past my data. So it's greater than any one of those. So it's going to be past. I'm going to just use this group variable that we've now created. And then what I want to put in there is new annotation. Cool. And then you can define your parameters here as normal. Font size 10. And then this alignment thing again of where do you want to align it. So in the little block that it gets to live in, I want to align it on the vertical axis in the center. So it's not too low or too high. It's in the middle of my bar chart, right? So then it's vertical alignment. I want to be setting. I want to be setting that equal to center. So if you run our code, it says, you can see it's 125, 145 would be kind of around here, and it's in the center. Cool. So that's how you can just put in some more values and more details and things. Cool. Yeah. So you can basically adjust every single part of this because they exist as a data object inside of your axis, which exists inside of your figure. And then you can adjust the values, and using your math operations you can perform on these specific functions. Using those math functions like mean and all those other statistical things we covered in the previous workshop, you can annotate that onto your graph using the internal features of Matplotlib. So that's just a quick basic introduction and explanation of all the different the anatomy of a pipeplot graph, basically. and that should be hopefully instructional and make sense. If you have
Yeah, it was good.
Okay, cool. Do you have any questions regarding any of this?
And just what should we do as homework, or what do you want to call it, to not make it scary? And would you mind then clarify what can I write and then share it to the GitHub?
Oh yeah. So the the post-workshop submission, which is
Yeah,
a very not so subtle
yeah.
literal homework.
Uh,
So basically, if you don't have any questions, I'll explain the homework portion of this workshop.
no,
So
all are clear and good. Thank you.
awesome, that's good to hear. So basically, for this workshop, one of the things I wanted to do with these workshops is allow you guys to get some code review and to figure things out for yourself and struggle. And if you have a problem, you can obviously ask, but to give it a go to figure out what you can figure out, basically. So with that in mind and all the different statistical things we've done up to this point and how data works and all that, and then also now with the graphs, and only having had a simple introduction to graphs, what I was thinking for the post-workshop submission is something that you guys might actually use is a time tracker.
Yeah,
So
okay.
I use a time tracker in my daily work, and it's very useful to know what project I spent how long on and all those kind of things for like billing a client reasons. But also, it's very useful for my personal projects because I can see I spent 80 hours on this project and this is what I got out of it. And over time, that duration will decrease, and it's quite inspirational to oneself to see that happen.
Yeah.
So, way back when I started programming, which is actually not that long ago, but there were a few guys that were making some really cool applications in that area that I really like to look at. So this one that I am now showing on my screen is made by Josh Avenir, and it's called Lug. And as you can see here, he's got all kinds of interesting statistics that he's pulling out of his data, because he tracks the start and the stop time of every piece of work he does and on what project, including his schoolwork, because he's still studying and all those kind of things. And then he comes up with these conclusions like his peak working time is 9 p.m. at night. He did this and this. This is when he works best. This is the project that he spends the most time on, and all those kind of things. And there's a lot of data going into that, and you define a lot of data and all those kind of things. And that makes a lot of sense to perform statistical operations on. Because you guys have been doing statistics with these data bits for now, because this is a data science orientated workshop series. So statistics is the easiest introduction. So basically, for the homework, I provided you guys with the explanation I just gave about what a time tracker is and why it's useful, and some examples. And then I defined the time tracker as including basic elements, such as a way to input when. So that is either how long or between what times or however you want to track that you did something. A way to input what you did. A way to store that data. So be that a JSON file you output, be that you integrating with a local database if you wanted to, or simply saving out your NumPy arrays to files, which you can absolutely do, or something like that. Any one of those you are welcome to try out or ask assistance with, and then also a way to visualize your data, and then perform some calculations on the data that you put in And then what conclusions do you draw based on that data? So that's the 5 bullet points that exists inside of the post-workshop submission section of the GitHub documentation. My notes basically. Basically what you then do is, keeping those elements in mind, what I'd like you to do is make a time tracker for yourself, one that you would actually be interested in using and can see yourself using in some way that you input stuff however you want. Be that through a command line, through a Matplotlib input box with a button, whatever you want to. Because Matplotlib also has all kinds of stuff for a user to input data and use that data and add it to all kinds of parts of your application. And then once you've made your project, put it up on GitHub, or progressively put it on GitHub as you're busy. And then either inform your GirlCode person of contact or me directly via email or Twitter, just that I should have a look at your thing, and then I'll write you some feedback and basically do a code review with commentary and advice and those kind of things.
Yeah, that's cool.
Cool.
Yeah.
Is that
and what is the deadline to send this stuff? What is the deadline?
There is no deadline. It's very much you develop your thing, and then when you feel that you have made an app that you would like some feedback on, I will give you the feedback.
Cool, thank you.
Yeah, so removing any of the normal pressures associated with homework. It's more of you are doing these workshops to improve your personal education from your own free volition. So there is no deadline.
Okay, thank you.
No problem. And
I will do that.
If you have any questions or queries, my contact details are there, or GirlCode person of contact can reach me. Either one you're comfortable with.
Sure, thank you.
No problem. Cool.
So for contacting you, I will use this Gmail or Twitter account that you provided. Okay, thank you. All are clear. Thank you.
No problem at all. Yeah. Cool. Enjoy coding, and
thank
I
you.
will communicate with my person of contact at GirlCode and figure out when the next workshop is, and you guys will be informed through social media.
Yeah, thank you. Thank you. Have a good weekend.
Thank you. Same to you.
See you.
Cheers.